Hi, this is Lee at Runtime Micro. If you've ever struggled with Arduino PWM or timer coding, this video might interest you. Runtime Micro is offering a free WYSIWYG Windows desktop application that generates correct PWM code for several Arduino boards. This application lets you utilize timers 1 through 5 for Arduino Nano, Uno, and Mega 2560. It calls out waveform pin numbers. It shows PWM channel identifiers. It then displays the output waveforms and shows you time interval and frequency data. Here's an example. For our first example, we're going to select our clock source. Then we're going to select a timer, timer 2. And we're going to select a PWM mode, fast PWM. We're going to go with the default output frequency, and this thing's going to start blinking for calculate code. And now that it's not blinking, I just want to show you. We could have asked for 1,000 milliseconds or some number we added in here. But let's not do that just yet. The program has calculated the correct register values based on these selections, all the parameters up here, plus what goes on in these interactive display controls. Now, because this is a timer 2, it only has limited modes, and I chose variable modes, variable frequency modes, which forces output compare register A to be fixed at whatever the program calculates. In this case, it's 250 minus 1. That only leaves this output compare register for varying PWM. Now, timer 2 has a special mode when you have the output compare set here that gives you a divide by 2. It toggles on whenever the timer reaches top. But we can turn that off. We need to be in this output compare mode to get a twin frequency output. The two frequencies are related 2 to 1, 500 hertz versus 1,000 hertz in this example. I'm going to show you what the oscilloscope revealed when I went to a 2560 and used these pins 9 and 10. So that was pretty easy. All we did was choose some parameters from limited selections and enter our desired frequency and calculate. For example 2, we're going to select the standard 16 megahertz clock. We're going with timer 1, a 16-bit timer, and we're going to select fast PWM output. This time we want an interrupt, and we don't want waveform outputs. We're going to shut the waveform outputs off here, and we're going to select 1,000 milliseconds instead of 1,000 hertz. This will generate a once per second interrupt. The code we get is minimal, but if you were to copy and paste this code to your IDE, which in this case is Visual Studio combined with Visual Micro's excellent add-in. So I take the code and I paste it right up here in Setup. And you notice on the timer mask line, we have a comment, and in the comment there's a little copy or a prototype for your needed interrupt. So if I didn't have this interrupt already defined, I've got this handy reference ready to go. So the interrupt doesn't do you much good unless you have something for it to act on. We're going to put this variable in the interrupt loop and increment it each time the interrupt fires. Down here, we're going to do a pin mode and define pin 13, which is connected to an LED. It's integral to the 2560 board, and if we don't do this, the LED will be very, very dim if it lights at all. In our main program, add a piece of code acting with seconds variable and a bitwise AND of the value of 1, which gives us the least significant bit of the second variable. So we're just looking at the least significant bit and deciding whether or not we're writing a 1 or a 0 to the output pin that's connected to an LED. At this time, we should be able to upload and compile. And I am seeing the LED on my 2560 cycle between being on and off in 1,000 milliseconds per time. This program is free for you to download. Just head on over to runtimemicro.com, go to the download section of the site, and click on the zip file for RTM timer calc.